So welcome back. And so to get started today, we are moving on into Unit 6, which Unit 6 is going to be everything to do with some more triangles. So we're going to be doing a lot of stuff with different types of triangles and classifying triangles and doing just different works with all these type of triangles. So today we are starting with 6.1, which is dealing with classifying triangles. So we're just going to be looking at analyzing and determining what type of triangle we're looking at. So let's go ahead and jump into that. All right, so the first thing we're going to look at is the key points part of this. And the way that you are going to classify triangles is by looking at either their side lengths and how they compare to each other, or you're going to be looking at the angle classification and how they apply to each other or relate to each other as well. So the first thing we're going to look at is we're going to look at our side classification. So the first one we're going to look at is we're going to look at equilateral. So the key thing I want you to look at is the word equal is written inside here. It's not spelled the way normally, but that's how it's spelled. But the word equal means all sides are congruent to each other. So right here, if you look at triangle number 1, this little mark, and this little mark means all those sides are congruent. So that means it is an equilateral triangle. All sides are congruent to each other, okay? So the next one we're going to look at is something called a scalene. So I want you to think equilateral and scalene are going to be opposites of each other. If equilateral means all the sides are congruent, scalene means no sides are congruent, meaning none of these sides are congruent. So if I wanted to make a mark, I'm going to make a mark 1, I'm going to make 2 marks and 3 marks, meaning all 3 of those sides are going to be completely different measurements. So that means it is a scalene. So again, equilateral, all sides, scalene, no sides, okay? And then lastly is the isosceles triangle, which you guys have already learned this, but the isosceles triangle means at least 2 sides of the triangle are congruent to each other. So if we look at example number 3 here, I have 2 marks on this side, I have 2 marks on this side, and that means those 2 sides are congruent to each other. So that makes this an isosceles triangle. And just to go back, I know that the base angles of an isosceles triangle are also congruent. So that means this angle and this angle are going to be congruent because those are the base angles of that. Okay? So again, side classification, equilateral, all sides. Scalene, no sides. Isosceles, at least 2 of those sides are congruent to each other. So these are going to be all of your side classifications. Okay? Now we're going to look at the angle classifications. So I'm going to be looking at all 3 angles of the triangle and determining what type of triangle it based off of that information. So the first one I have is a right triangle. So I know right means 90 degrees. That's what it means. So if your triangle has one angle that is equal to 90 degrees, if it's truly a triangle, only one of those angles can be 90 degrees. But if one angle is 90 degrees, then that means it is a right triangle. So looking at example number 4 here, I have this little box right here, which means a 90-degree angle. So since this angle right here is 90 degrees, that makes this a right triangle. So since it's 90 degrees, that is a right triangle. Okay? Same thing for the next one. So on number 5, I have an obtuse triangle. So an obtuse triangle is one angle that is greater than 90 degrees. So I know that little box is 90 degrees. So if I have one angle, because if it's a triangle and it's greater than 90 degrees, it can only have one of those. If I have a triangle where the angle is greater than 90 degrees, that is an obtuse triangle. So if I look, that's less than 90, that's less than 90, but this angle right here is going to be greater than 90. So since that angle is greater than 90 degrees, then that means that is going to be an obtuse triangle. Obtuse, one angle that's greater than 90, okay? On number 6 here, I have an acute triangle. So we got to remember, acute is less than 90. So if I have all of my angles that are less than 90 degrees, then that means this is going to be an acute triangle. So look at number 6. If this angle right here, and this angle right here, and this angle, all 3 of those angles look like they are less than 90 degrees, this is going to be an acute triangle, okay? And then the last one is going to be the same thing as equilateral, but now I'm looking at the angles. Equiangular means all the angles are equal to 60. So if you have an equilateral triangle, that automatically means it's equiangular. If you have an equiangular triangle, it automatically means it's equilateral. Those are basically the same thing. So number 7, all 3 angles are congruent to each other. I know that since I have 3 angles that are all congruent, they're all going to be 60 because they add up to 180. So again, right angle, 1 right angle, obtuse, 1 obtuse. Acute means all the angles are acute, smaller than 90. Equiangular means all the angles are going to be congruent to each other, which technically speaking, equiangular, all less than 90, that's going to be an acute triangle as well, but it goes further because it's equiangular, okay? So we're going to take this info, we're going to apply it to our examples, and hopefully we can get going with this. All right, so let's look at example number 1. On example number 1, it wants you to classify the 3 triangles given below. So I have 1, 2, and 3 triangles. So whenever you're looking at a triangle, you can either give the classification with its side lengths, its angles, or you can do a combination of both, because if you know enough information, you can go ahead and tell both of those, okay? So looking at example number 1, I want you guys to know, so let's go ahead and look at the angles first, because you always want to put the angles first if you have that info. So right now, if you look, I have an angle here that's 26 degrees, I have an angle here that's 26 degrees, and I have an angle here that's 128 degrees. Well, out of my 3 definitions up top, all of them are equal, so that's not equiangular. I have one angle that is greater than 90 degrees. So automatically, if I have one angle that is greater than 90 degrees, that makes it an obtuse triangle. So on the first one here, it is going to be obtuse. And now we're going to look at my side lengths. So if you look, I have 2 sides that are congruent and 1 side that is not. Well, up on my side lengths, I either have all of them congruent, none of them congruent, or just 2. So if I have just 2 congruent, I know that's an isosceles triangle. So since I have 2 sides that are congruent, this is going to be an obtuse isosceles triangle. So that is an obtuse isosceles triangle, okay? Now look at the next one here. So let's go ahead and analyze my angles first. So if I look at all 3 of my angles, I notice I have one 90-degree angle. So 90-degree angle means I have a right triangle. So this is going to be a right. And now let's go ahead and analyze my side lengths. So if I look, I have 7, I have 11.2, I have 13.2. None of those sides are congruent to each other, so that makes this a scalene triangle. So since I have a right triangle and a scalene triangle, that means I have a right scalene triangle, to be more specific. And all of this information is going to come to help you to solve problems whenever you use this definitions, okay? And now the last one, if you look, I have all of my angles are congruent, so that's going to be equiangular. And if you look, all of my sides are congruent, so that's going to be equilateral. But you don't necessarily need to put equiangular, equilateral triangle. You can just put one of those, because if you have one of those, you know the other one is true. So you can either put equiangular or equilateral here. So I'm going to go ahead and put equilateral. Because when you have an equilateral triangle, you know it's equiangular. If you have an equiangular triangle, you know it's equilateral. Okay? So now let's jump over to example number 2. Okay, so on example number 2, it says, if you are given the angles of the triangle, you need to order the sides from least to greatest. If you are given the sides of the triangle, you need to order the angles from least to greatest. So right now, if you look on this first example here, I'm given all my angles. So I need to list all the sides from least to greatest. So right now, what you need to know is the side opposite of the angle is going to determine the order, okay? So I'm going to go ahead and list these like 1, 2, and 3 as in least to greatest, okay? So right now, let's find my smallest angle. So right now on this one, my smallest angle is going to be 30 degrees. Anytime you have a triangle, the side opposite of that is going to list the order of the measurements of the sides. So for instance, if the smallest angle is 30 degrees, So I'm going to go opposite of that 30-degree angle, and that side is going to be the least of the three. So I'm going to put a 1 here to analyze that's the least, okay? I'm going to use a different color. So now out of 30, 65, and 85, the next one, or the next lowest, is going to be 65. So if I circle 65, the side opposite of that is going to be the next biggest side. So I'm going to call this side 2, okay? Now I know that my biggest angle is going to be 85. So the side opposite of that is going to be the biggest. So again, I listed it from least to greatest. So 1 the lowest, 2 the middle, and 3 the highest. So now I can go ahead and list those from least to greatest. So right now, that means my smallest side is going to be VT because it's opposite the smallest angle. So VT. So my smallest side is VT. Okay. My next biggest is going to be opposite the middle angle. So 65, opposite of that is VU. So the next one's going to be VU. Sorry, that looks like a double V. Let me fix that. So V and U. Okay, and then now the last side, which is opposite the biggest angle, is going to be TU. So T and U. So those are going to be your sides listed from least to greatest, because opposite of the lowest angle is the smallest side, opposite the middle angle is the middle side, opposite the biggest angle is the biggest side. And the same thing goes for the side measurements. So if I go opposite of the biggest side, that's the biggest angle. If I go opposite the smallest side, that's the smallest angle, and we're able to list those from smallest to greatest. So let's go ahead and do that with this one down here. So right now, if I look, I need to go from least to greatest. So right now, F to H here, or F to whatever that is going to be your smallest side. So I know opposite of that side is going to be the smallest angle. So this is going to be the smallest angle, 1 right there, okay? My next biggest side is going to be 14. So opposite of 14 is going to be this angle down here, and so that's going to be number 2, okay? Then now my biggest side is going to be 21 here, and so now that's opposite of that is going to be F here, so that's going to be my 3rd biggest side. So now if I list these from least to greatest, smallest side, opposite of that's the smallest angle, so G. Middle side, opposite of that is going to be E. Biggest side, opposite of that is going to be F. And so now actually you can look, if I was to look back at example number 1, I have 26 and 26. Since those two angles are congruent, I know those opposite sides are going to be congruent as well. 26, 2.5, 26, 2.5. So this information can actually help you to find further information if you're not known, or help you to determine if something's isosceles or not, okay? All right, so let's jump over to example number 3. All right, so look at example number 3. It says, given the information below, we need to find the value of x. So right now it's showing the measure of angle 2 is equal to x plus 94. So right here, angle 2 is x plus 94. So I need to use the information to try and figure out the value of x that's going to find you the measure of angle 2. So we need to find the measure of angle 2 first, okay? So right now if you look, I have 2 triangles. And something you need to notice is the relationship of the sides, because I don't have any, I have 1 angle measurement down there. So right now looking at my sides, on this triangle I have 2 sides that are congruent. Well, by definition, that's an isosceles triangle. I know that the base angles of an isosceles triangle are congruent. So on this triangle, these are my base angles. So if this is 47, that means this angle right here is also going to be 47. So I'm going to write 47 in here. Well, if you look, I have 2 lines that are crossing each other, and I know 2 angles that are vertical to each other are congruent as well. So if this is 47, that means this angle right here is going to be 47. So this is 47. Okay? But now if you look, the triangle up top is also going to be isosceles. So since this is an isosceles triangle, that means my 2 base angles are going to be congruent to each other. So if this is 47, that means this is going to be 47. Okay? So now I can find the measurement of angle 2 because I know all 3 angles of a triangle add up to 180 degrees, right? So I know angle 2 plus 47 plus 47 is all going to add up to 180 degrees, right? So angle 2 plus 40 and 40 give you 80, 7 and 7 give you 14, 80 and 14 would give you 94. And then I'm just going to subtract 94 on both sides to figure out what angle 2 is going to be equal to. So I should get 86 is going to be my measurement of angle 2. But it's asking the value of x. Well, I know angle 2 is 86, so I'm just going to replace measure of angle 2 with 86 here. So 86 is going to equal x plus 94. So that means I just need to subtract 94 on both sides. So I'm going to be doing 86 minus 94, which is actually going to end up giving me a negative sign, right? So 86 minus 4 is going to end up giving you negative 8. So your final answer for x is going to be equal to negative 8 because we're using the value or the measurement of an isosceles triangle to find those. Okay? All right, guys, so now the last thing we're coming to is the challenge question. I really want you guys to try and do this challenge question because a lot of times some people try and skip over it. The challenge question is going to give you a gauge to see if you're ready to move on to your skill check. If you can do the challenge question on your own and you bring it up to me and show me that you got the right answer, this is telling me you're ready to move on. But if you're struggling with working with this, that means you're probably not too ready to move on and you need a little extra help to get there. So that means you can go try the quizzes to do a little extra work, or you can come and ask me about this challenge question and we can work it together and try and figure out where your misconception is, okay? So good luck with your work, good luck with your skill check. Holler at me if you need any help.